2.2 Polynomial Functions. Okay, so polynomial functions, we're just going to basically look at a little bit with the transformations, and then the leading coefficient, the leading term, and so that kind of tells you what the end behavior is and how many possible zeros it could have and turning points involved. Okay, so okay, we kind of already talked about graphing transformations. They call this the leading term test. Okay, so they're going to give you functions that are slightly more crazy. So like not just an x squared, they'll give you like something like this, like the quantity of x minus 3 to the 5th power. Okay, so in the past we did more like cubics, but if I have a 5th degree polynomial, first of all, what does it look like? John Travolta. If I have minus 3 on the inside of the parentheses, what direction does it move? To the right. Okay, so this is simply going to move 3 units to the right, and it will just look like a John Travolta. Okay, the 5th degree basically makes him like more skinny and let's say more rigid instead of like smooth curves. It'll kind of be like, you know what I'm saying? Exactly. Okay, so they're going to ask you, they're not going to ask you as many questions about these functions, but they're going to ask you, of course, about the end behavior. Okay, so what's the end behavior of this particular function? Perfect. Okay, so that part is pretty easy. Then they're going to make it, of course, a little bit more complex, and they'll add more terms in here that you're not going to really be able to do without a calculator. Okay, but what you should know is that when you type it into the calculator, what it could potentially look like. Okay, if I was going to type that in, what should this thing look like? It should have end behavior that looks like a parabola. It should end up looking somewhat parabolic, but in the middle, it could potentially do some more wiggling. Yes, Mari? Oh, just kidding. That was a stretch. Sorry, I thought you were asking a question. So if you do graph this into the calculator, which some of you guys are doing, it should look like a W. Okay, so really all we need to pull out from this section is what is the end behavior of this function? Okay, what is my right end doing? They're both going to infinity, fair enough. So the right end and the left end are both going to infinity. Okay, so just kind of having a general sense of what is going to come out when you type a function in. Okay. The other part is potentially how many zeros you should be seeing and how many turning points. Okay, and this is really, these two pieces right here are really important in understanding functions. Okay, zeros are, what are zeros in terms of the graph? Where it crosses the x-axis. Turning points are just like your maximum and minimum spots. Okay, so by definition, a function can potentially have, so let's say our function happens to be x to the nth power. Okay, if it has to the nth power, the function can have, at the very most, n zeros. Okay, so if I have a x to the 5th, like question number 1, how many zeros could the function possibly have? Potentially 5. Okay, but does it definitely have 5? No. Okay, so it could possibly have 4 zeros. It could possibly have 3 zeros. It could possibly have 2 zeros. It could possibly have 1 0. Is it possible to have no zeros? Okay, so think about, if I know that this function is a John Travolta, and the end behavior says one end goes up and the other end goes down. At some point, is it possible for this function to never cross the x-axis? No. Okay, so that means any odd function has to have at least 1 0. Okay, but what about a parabola or an even function? Let's say we're talking about an x to the 6th. How many zeros could it potentially have?
2.
X to the 6th. So it could have 6, it could have 5, it could have 4, it could have 3, it could have 2, it could have 1, it could have 0. Yes. Okay, so imagine a parabola that just exists above the x-axis. It never crosses the x-axis. Or -1, that's upside down. Okay. As far as turning points go, okay, f of x can possibly have at most n minus 1 turning points. Okay, so I think it's easiest to kind of start small and then get bigger. So if you think of an x squared function, so x squared can potentially have how many turning points? Well, definitely has to have at least 1 turning point, right? 1, right? Because you have a parabola, it's got to turn and go back up. John Travolta, x cubed, could potentially have 3. Okay, so John Travolta could start up, turn, go back up, turn, and go back down. Cubic. Is it possible for a John Travolta to have 1 turning point? Okay, so if it's John Travolta, I end here, I end here. If I have 1 turning point and I go back up, is it possible for it to have only 1? No. Okay, so turning points comes in sets of 2. Okay, if it goes up, it's got to go back down for it to have an end behavior of negative infinity. Okay. Does that kind of make sense for those? Okay, so here's what they're going to do. They're going to say, state the possible real zeros and turning points then find them. Find the actual. So they're only going to ask you to find actual zeros. Okay, and not the actual turning points, but just to understand what you're dealing with. Okay, so let's say our function is x to the 4th minus 3x squared minus 4. Okay, so my goal is to be able to do this without using a calculator. Okay. Yeah. So how many possible real zeros could there be? Possible real zeros. How many could there be? There could possibly be 4, right? X to the 4th. How many possible turning points could there be? 3. Okay, so we answered that part. Now, how do we find the actual zeros? What if we don't have a calculator?
When would we have to use a calculator?
When they tell you to.
I would be, I'd be in the woods.
If you go to college, you can't use a calculator in your math class.
Why there?
Yeah, why are we not allowed to use a calculator?
Okay, so this is how you do it. All you're going to do is set the function equal to 0. Oh, good. And just solve this as a polynomial equation. Okay, anytime I have a polynomial that's not just an x linear function, and if I set it equal to 0, what do I need to do? Factor it. Okay, so I can use which method to factor this? The easy method I can use. Okay, even though it's x to the 4th, I can use the easy method, but instead my quantities are going to be x squared. X squared plus this, x squared minus this. Okay, so what two numbers multiply to negative 4 and add to negative 3? Oh, negative 4, positive 1. Okay, so after I factor the function, what do I do algebraically? Set them both equal to 0. So I have x squared minus 4 is equal to 0, and I have x squared plus 1 equaling 0. Okay, so if I solve the left-hand one, what would you do? What's x squared plus 4 equal to 0? Add 4. Okay, and then square root. So square root of 4 is what? Plus or minus 2. Don't forget the plus or minus. There's two zeros that pop out. Okay, what about the other equation?
The other one is I.
Okay, so is that a real number? No. Okay, so because it's not a real number, we're not going to list it. It's not a place where it crosses the x-axis. Okay, so there are only two real zeros for this particular function. Okay. Are we good with that? Can I do one more? Okay, I'm going to do two more actually. I agree. That was terrible. I apologize for that. Oops, and graph. Okay, so they're also going to ask you to find the zeros and graph the function. Okay, so again, trying to do this without a calculator. Okay, so the first thing I'm going to do is just find the zeros. Okay, so what do I do with the function? Oh, sorry, I wrote that down wrong. 3. Thank you for catching my mistake. There we go. Okay, so how do I find zeros? Set it equal to 0. Okay, so how am I going to solve this equation? Exactly how many, by the way? An x squared. And I'm going to actually pull out a negative because the very first term is a negative. So you always want to pull that out when you can. So I'm going to pull out negative x squared. So what's going to be left out of a negative x4 to the 4th if I pull out x squared? X squared. And then I'm going to have plus 3x minus 2. Very good. Okay, so I'm almost done. Can I factor x squared plus 3x minus 2? Okay, what two numbers multiply to negative 2 and add to positive 3? Yeah, maybe not, right? Okay, so how am I going to solve that? Yeah, quadratic formula. So really quickly on the left-hand side, what's my 0 on this one? On the left. 0, okay. So over here, then I'm going to have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we get, let's see, 9 plus 8, right? 9 plus 8 is 17. over 2. Okay, so you can't break 17, but that's going to be technically 2 zeros there. Okay, so when I go to graph this is going to be an interesting graph. I'm going to show you guys what it looks like. Okay, so before I go to do this, first of all, looking at the leading term, what is it potentially looking like? A parabola, and specifically what direction is the parabola? Downwards. Okay, so we have this parabola that's going downwards. It potentially is going to wiggle in the middle, and actually is going to wiggle. Okay, if I graph my zeros, okay, I have a 0. I'm just going to go ahead and be a little bit lazy here and say, well, this is going to be -3 plus the square root of 17 over 2, 17. Anybody know what that is as a decimal? Maybe we should throw that in there really fast. Well, that's right. I'm going to throw this in the calculator. So it's 0.56 and yeah, well,
What about when you take your
without a graphing calculator, how about that? Well, that's like 0.56. So let's call this 0.56. And this is going to be 1, 2, 3. -3.56. Okay, so those are the zeros that this function has to go through. So what is the end behavior of my function? Down, right? So the end behavior, so this one has to go down, and this one over here has to go down. Okay, so watch what's going to happen. This is going to be kind of interesting. You gonna hit that right? Well, that wasn't great, but. Okay, so if you graph it on the calculator, it should look something like that. Notice what happened at 0. What happened at 0? It what? Okay, kind of. No.
No, it touched it.
It touched it. It bounced off of it. It did not cross through it, but it bounced. Okay, so the reason for that is, see how this original thing was x squared? Okay, so it's technically giving you 2 zeros. This, anytime you have a quantity that's squared, it'll cause the graph to bounce off of the x-axis. Okay, so that piece right there was a bounce. Bouncer, I wrote bouncer, that's right. Okay, anything with a linear quantity like these other two, since they were linears, those are going to cross through. Okay. Okay, so making this a little bit simpler, let's do. Okay, thank you. How close are we? Okay, well, maybe I should just pull out an assignment. I won't give you a long one. Just calm yourself. You have a nice long weekend. So you're gonna have some travel time? Oh, I should have known. Should have known. All right, I'll give you. There, that's pretty easy. Oh, page 104. Sorry, thank you.